I'm here to present this series of videos to perform retrospective image analysis for long-term demography using Google Earth imagery. The set of videos are made so you can easily follow the protocols that we used and use this for other case studies that you want to analyze. The protocol is divided in different steps. So first, we will show how ground truth individuals can be collected from the field, then how to download Google Earth imagery, how to segment different individuals that we have observed, how we can integrate this with deep learning as well, how we do this georeferencing accurate enough to do the retrospective analysis, how we transform this to recruitment data, and how we finally output valuable information for managing or for just population analysis. So all the protocols for all these different stages and steps can be found within the data folder of this project. It will be something like this. You can find on the description of this video and also on the supplementary materials. You have all these different protocols, including a ReadMe that explains a little bit the general. This is ReadMe and includes like what are the used software for any step of it, and a brief description, and all of these different documents explain in detail all of the steps, but the videos that go with them are quite useful maybe to see more the whole picture and how actually what we did in all of the steps. So just for a bit more context, this is part of a project where we are analyzing invasive plant growth in different areas, and we realized that Google Earth imagery is quite powerful, and there is good temporal and spatial resolution that we can leverage for analyzing demographic trends, and especially since invasive plants are quite abundant and sessile, we can track them in time. So this is the main idea. We have used a couple of invasive plant species for this analysis. One is Opuntia, and the other is Carporotus edulis. But there are other models that can be used, other species that can fit in this framework, in this pipeline, and we have discussed and showcase them in the manuscript of this project. I wanted to highlight as well that we tried as much as we could to develop this in open access tools. So we are using Google imagery like Google Earth Pro to download the image, which is free and available. We are using QGIS as a spatial mapping software. We are using open access, open source segmenting models, and open source as well plugins that can be installed. We're using R for some analysis as well, and we present a method to use deep learning with a software that it's not open access, is ArcGIS Pro, because it's very easy to use in case you don't have like expertise in AI and machine learning in general and how to train algorithms. But we also offer a few options that you can use for free. So for example, to develop deep learning for object detection with spatial information, you can either use the deepness plugin in QGIS or just train the image using different softwares, for example, label with RoboFlow, and then training the algorithm with YOLO, with an open available version of YOLO in a Jupyter notebook, for example. So you can also not be dependent on having a very good computer to do the deep learning part. With further ado, let me just leave you with the rest of the videos of the series, and just let you know that if you have any questions, anything, my contact details will be in the description. Feel free to write me if you want to develop this for other species, and I hope you have fun looking at these videos and trying this for yourself. Thanks for watching, and subscribe to the channel to see more videos like this.